Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we proceed with next lecture, that is delta modulation. Okay, delta modulation okay. In PCM, the signaling rate and transmission channel bandwidth are quite large since it transmits all the bits which are used to code the sample. Okay, for pulse modulation, you have analog and digital. Okay, previously you have learned about PCM. So delta modulation is part of digital pulse modulations. So in PCM, the signaling rates is large because the bandwidth are large because it's transmit all the bits. So for example, you have 0 1 0 0 1 1. Okay, and for data modulation, it's transmit only 1 bit per sample. Here the present sample value is compared with the previous sample. So it just compare the current value with the previous value. And this delta modulation is a technique to convert analog to digital. And compared to PCM, delta modulation use simpler circuit. And okay, it's a series of pulse with 1 and 0 bit. Okay, for example, here is the as I mentioned before, the delta modulation is single bit PCM mode. Okay, it's single bit PCM mode, and it's logic 0 if the current is smaller, and 1 if the current sample is larger. Okay, for example, you have signal like this. You have signal like in the red signals. So okay, it's just compare the current with the previous. For example, here, okay, the current is okay. For example, here it's 0 because current is smaller than previous. Okay, this one also 0. Okay, for example, here you have this one is A and B, and you can get the A value is smaller than B, so that's why the logic is 0, and that is smaller 0. Okay, this one is 1 because 1 2 1 2 2 4. Okay, this one is because it increase here, increase. Okay, this one is belong to this. It's increase here, so it's become 1 because the current is larger than the previous. Okay, this one also here. Yeah, this one is because it's increased. So this bit it show compared to the previous value. Okay, as I explained before, this is the graph of delta modulation. You will have this bit, this binary data, based on comparison the current value with the previous. The difference between the input signal xt and staircase approximated signal is confined to 2 levels. So here we have delta here. Okay, delta is the difference between the signals. That means the input and the staircase. Okay, and if the different positive, then the signal is increased by one step. And if the difference is negative, then the approximated signal is reduced by delta. So this is the delta, and okay, ST is original signals, and UT is the staircase signals, and we have TS for predict of the staircase signal. Okay, and this one is same as before. If the step is reduced, 0 is transmitted, and if the step is increased, 1 is transmitted. So for each sample, only one binary bit is transmitted. Okay, and in this delta, in this delta modulation signal. Okay, let's look at the block diagram of delta modulations. So this is the block diagram of delta modulation transmitter, and the other one is for the receiver. Okay, for the transmitter, we have a low pass filter, and then a comparator, and a product modulator, and pulse generator, quantizer, and accumulator. So the message signal, this is message signal, that is the original signal, empty. Empty is transmitted to low pass filter, and this low pass filter pass the low frequency component and eliminate the high frequency component. So it also referred as aliasing filter. And then the output of low pass filter, this one is given to comparator unit, which compare the message signal empty with the arbitrary signal and apostrophe T. So it's compared the previous signals, and then the difference of that means the difference between the current signal and previous is then subtract the empty, subtract the M apostrophe T, and the different signal is the input of the product modulator. And this the other signal that also act as the input to the product modulator is the pulse generator, because this delta modulation is part of digital modulation, so pulse generator is needed, and it is multiplied into this modulator multiply the pulse generator with the output of comparator, and then the output of the modulator is a pulse signal, whose the pulse will be equal magnitude having polarity either positive or negative, because this modulator already multiply the pulse generator with the comparator output, so the output is pulse either positive or negative. And then the output of the modulator is given to the quantizer. The quantizer generate the output in the form of the step. So this one is to generate the form in the output of step. That's mean the stepwise signal. Okay, the function of quantization make them previously is a pulse signals, and then it's become stepwise signals. And then the output of the modulator at the same time going through the feedback path and provided to the accumulator. The accumulator is a function to store the signal for further operation. And then the output of the accumulator behave like the second input of the comparator. So this is the current and this is previous. That's why comparator in delta modulation is compare from current signal with the previous signal. So this is the block diagram for the transmitter. And then for the receiver, it is opposite of transmitter. So it has accumulator and then low pass filter with the delay unit. And this the input is the binary input, and then together with the delay. After a delay, this means after summation with the delay, it increase by the step size of delta. For example, if the case of binary is 0 and the stepwise is decrease. If the binary is 1, it generate increasing signal. And then the output of the accumulator is provided to the low pass filter to smooth the staircase signal in order to generate the original signal. So the advantage of delta modulation, it was found that at lower bit rates, delta modulation is better than standard PCM. And at lower bit rate, due to transmission of 1 bit per sample, it permits low channel bandwidth. So it has low bandwidth. And delta modulation works with lower channel bandwidth. This makes the system cost effective and simple to implement. So it is cost effective and simple to implement. And the feedback mechanism present in this modulation signal ensure the quick and robust delivery of data bits. And also in this delta modulation, ADC is not required, so it's permit easy generation and detection. Okay, but delta modulation also have drawbacks, and two major drawbacks in the delta modulation is slope overload distortion and granular or idle noise. So slope overload distortion is like this, and granular noise like this. Okay, slope overload distortion when the slope of the input signal is greater than slope of the output. For example, here the signal have steep this means have steep gradients, and then the step size is same. So that's why the step size of the step signal is not similar with the original signal. So this is overload noise, and the other noise is granular noise, where the fluctuation effect due to decrease and increase in the step size. So there are more increase and decrease, so it's become granular noise. Or further explanations, for slope overload distortion, okay, we have XT, the original signals, and then UT, the staircase approximation. And this distortion arises because of the large dynamic range in the input signal. So this means the from here to another point, it have large dynamic range. And we can observe from figure, the rate of rise of input signal xt is so high that the staircase signal cannot approximate approximate it. The step size delta become too small for staircase UT to follow the step segment. As I mentioned before, this step size is same, but the increasing gradient is so high, so it cannot follow the original signals. So this error is known as slope overload distortion. And to reduce this error, the step size must be increased when slope of signal at T is high. So the solution is increase the step size. Increase the step size. And the second noise is granular or idle noise. Granular or idle noise occurs when the step size is too large compared to the small variation in the input signal. Okay, before this, slope for slope overload distortion, delta is important for this. But for granular noise, the this period is important for granular size. This means the step size is too large compared to small variation. So this means the step size is larger compared to the original signal that is flat. So this means that for every small variation in the input signal, the staircase signal is changes by large amount. That is delta because of large step size. Figure show that when the input signal is almost flat, the staircase signal UT keep oscillating by plus minus delta. So this means the original already flat, but the staircase approximation still have plus increase and decrease, and this error is called granular noise. And the solution to this problem is to make the step size small. So for previously increase the step size, but this one is decrease the step size. And to overcome the drawback of data modulation, in order to overcome the quantization error due to slope overload and granular noise, the step size delta is made adaptive to variation in the input signal. So you use adaptive size. This means changes the step size, particularly in the steep segment of the XT, the step size increase and the step size decrease when the input is varying slowly. So for high gradient, the step size is increased, and for flat, step size is decreased. This method is known as adaptive delta modulation, ADM. And the adaptive delta modulation can take continuous changes in step size or discrete changes in step size. Okay, and PCM versus DM. This is the adaptive delta modulation, where the modulation method is similar to delta modulation, except the step size is variable according to the input signal in adaptive delta modulation, whereas it is a fixed values in delta modulation. So it's same with the delta modulation, except for the step size. Step size is variable. Okay. The last one is the compare PCM versus DM. Conventional PCM use much higher bit, and for DM only use one bit that is lower than PCM. However, DM suffer from slope overload noise And with the consecutive or string of 1 or 0, slope of ADC is less than slope of analog signal. And to overcome the drawback of DM, adaptive DM is proposed, where the step size is automatically reduced or increased depending on the amplitude of the analog signals. And the step size is increased until the output catch up the analog signal. When the alternative sequence of 1 or 0 occur, is going back to the minimum step size. So this is the characteristic of the ADM. Okay, that's all for today. Okay, see you in the next lecture. Thank you. Assalamualaikum warahmatullahi wabarakatuh.